Hi, Tim Skell here, ABB HVAC Application Engineering. Today we're going to talk about setting up the ACH580 when you have a fan array application, or it could be any multiple motor application, and you want to enter the motor nameplate data into the drive and also have some other configurations work correctly specifically for a multi-motor application. So let's take a look at how to do that. So I'm going to come into the menu, go to Primary Settings, hit Select. I'm going to go to HVAC Quick Setup. If you've seen enough of my videos, you know I love working in the HVAC Quick Setup. Covers most of my needs right in here. I'm going to scroll down to the motor nominal values because that's where I entered my motor data. Motor nominal values, I'm going to select that. And first question it asks me, is this a single motor or a multiple motor application? So what I'm going to do is use multiple motors because I don't feel like doing math today. I'm going to let the drive do the math for me. So I'm going to select on multiple motors. I'm going to now enter into the drive how many multiple motors do I have for this application. I'll just say it's a small 2-fan array. So simple 2 motors here, but I could go in here, hit the right arrow, change this all the way up to 18 motors. Technically, the drive could run more than 18 motors, but at some point you get to an application-wise, does it make sense for a single drive to run all 18 motors or not? Or should we go with more of a maybe one drive per row or one drive per column or a checkerboard approach to that fan array? So we limited it at 18 for this particular functionality. This example, we're going to go ahead and assume just 2 motors. So I got my 2 motors here, hit next. Now what I'm going to do is enter the nameplate values for the single motor. So what is one motor's rating? I'm just playing on my little demo case here, so it's a small drive. So just for fun, we're going to say it is a 1/2 amp motor. So all of my motors, both of my motors, each are 1/2 each. I can go ahead and enter my speed of the motor. I can enter the voltage. So we'll say it's 1760 RPM motors at 460 volt. I can enter the frequency of the motor. I can also enter the horsepower of my specific motor. So let's go into here and let's say it is a 1/2 horsepower motor. So each one is a 1/2 horsepower. So 1/2 amp motor, 1/2 horsepower. I'm letting the math be really easy today. So there's some other information. It's not too critical. Things like your power factor, your motor, you can skip over that. Now I'm going to come into here and hit next. So I got my summary. It's telling me I got 2 motors. Each one is a 1/2 amp. Each one is a 1/2 horsepower. Then it tells me, hey, combined, all my motors together are 1 amp and 1 horsepower. Now you can see why I picked easy numbers to make the math easy for us. If I wanted to, I could come in here and change any of these values if I realize I fat fingered something. So if I realize those motors are really 0.4 amps as an example, or 0.6 amps, I could go ahead and change that. You can see it updated my 0.6. Now I really have 1.2 amps total. So I've got my motor data in there correctly. And what's really, really cool about this is we also change other settings specific to a multi-motor application. So in my younger days, I taught a boatload of startup classes dating all the way back to the ACH550. One of the questions I would get, Tim, if I got a multiple motor application, what do I need to do to the drive that's different from the typical single motor application? So let's take a look at what those are. First off is it changes the start mode from normally it'd be a flying start to what we call constant time, but really what that is it breaks the motors on start, gets them all lined up, and then starts them together. So what happens is if you got a large fan array as an example, let's say it's a big one, a 5x3 array, so you got 15 motors, and all of a sudden the power goes out, maybe you're in the process of ramping up your generators, things are coasting down to a stop, and you got some variables in there as far as the bearings, the cones on the fans, maybe you got some backdraft dampers in there that are working a little bit better with some than with others. And what happens is all the motors start coasting down at different speeds from each other. If you get too much of a delta from your fastest motor to your slowest motor, when the drive goes to try to do a flying start and catch all of those motors, it increases the chance of it tripping out on overcurrent if there's a big speed difference between your fastest and your slowest motor, because the drive is kind of just averaging them all together, and unfortunately the average is different from what each one is really running at. If all the motors are synced up really well, the flying start works okay, but we're assuming kind of the worst case that there's a chance that all those motors aren't synced up too well. Maybe another situation might be you got a stop command and maybe you don't have a good backdraft damper and some of the fans are actually spinning backwards but at different speeds from each other. That's another reason why on the start, first thing you want to do is break everything to a stop and then ramp them up. So that way the drive does not trip out on an overcurrent. So a much more reliable solution when you do these kind of tricks in those kind of application situations. So the start mode has been automatically changed for us. What else? Energy optimizer has been disabled. So one of the neat things with the drive is it can vary the voltage based on frequency. Normally, that's how it works for just controlling speed, but it can also play with that voltage at a specific frequency to try to find that sweet spot for energy efficiency. Works good with a single motor application. When you get a multi-motor application, it just doesn't work as well because you got all those motors going on there. You just increase the chance of maybe getting a bad spot where maybe you'll stall out. So by default, we will disable the energy optimizer functionality so you don't have problems in that multiple motor configuration. Your volts per hertz ratio, similar to the previous conversation, it's just more reliable with a linear configuration than a squared configuration for your volts per hertz ratio in a multiple motor with induction motors. The magnetization time, just talking about how much it's braking the motors. We talked about it braking at first to bring the motors to a stop. So 3/4 of a second is how long it's going to brake those motors before it starts ramping them back up. It's letting you know that, hey, we're running in scalar mode. So there's scalar and vector mode in drives with induction motors, multiple motors. Typically, scalar, you're going to get better control and functionality at the end of the day when you got a multi-motor application, more reliability there. And of course, the last is the motor type. We're assuming it's an induction motor with these above settings. So if you did not have an induction motor, this is your flag to say, hey, let's take a look that maybe this isn't the right configuration for it. But a lot of what you're dealing with is going to be at the induction motors. And then another one of those little cool tricks that not everybody knows about is what about safeties? Typically, if I have like a high static safety on my fan array or any fan application, if my safety opens up, typically I have my drive coast to a stop. But what we've done is we've set it to ramp to a stop if one of our safeties opens up. So why do we do that? Well, think of those situations where you got those quick generator transfer tests and you might have those interposing relays between your safety and the drive on the digital inputs. What we found is when the power goes out quickly, the drive can ride through that a lot of times, but that 120 volt control relay just dropped out, which then tells the drive to stop. And if it's in a coasting situation, now you have that challenge of trying to catch multiple motors that are all coasting down, possibly at different rates from each other. So by leaving it set to ramp, when my safety opens up, the drive proactively starts ramping the motors to a stop. And in that process, it keeps control of the motors. So one of those really cool application things that we've learned over the School of Hard Knocks on how to get a drive to be able to just continue to power through quick power losses, whether that's a generator transfer test, utility power flickers, you name it. So I'm going to go ahead and hit next now. Here's a chance if I wanted to change my limit. So let's say if I had that fan array and I realize at the end of the day I'm going to be going up to, let's say it's 82 hertz like my air handler 2 at the factory here. So max of 82 hertz and go ahead and hit next. And now it just gives me one last chance. Hey, you're getting ready to exit the assistant. Do you want to save everything we just entered? Yes, go ahead and save it. And there you go. You just set up an ACH580 VFD to be able to run a multiple motor application. You went ahead and just told it how many motors you had, what the motor nameplate data was for a single motor. In this, we're assuming all the motors are identical. That's an important key part here with this functionality. And then also all those key parameters and settings that are a good idea to change because you got a multiple motor application. We went ahead and automatically changed those, gave you the summary of what we changed. So if you wanted to go back and override anything we changed, you can still go back and override it. So there you go, multiple motor setup with the ACH580. If you have any questions, reach out to your local ABB representative or your friendly ABB factory application engineer. Thank you.